start from the bottom and then up?
So if you start from the bottom, it means that the bug's going to start close to the bulb and then go back and forth. I don't know. I don't remember the problem specifically now. If it said the bug starts off and then flies toward, you have to start away farther. Okay. All right. So maybe let's take a look at 3. Do a few true false. Let's see. Let's do B first. A graph with only one point is always the graph of a function. So if I give you a graph with just one point on it, is that always going to be a function? It's not an easy question, huh? Tom, thought or idea? False? Why are you going? Tell me, how many people are going with false? I heard a couple no's. Where are my falses? Put your hand up. You said false. True. How many people think it's going to be true? All right, I have a couple. How many people really have no idea? Good. I appreciate that. All right. So give us a little bit of reasoning for false. Why this one might be false.
Well, I'm just guessing relating back to time and distance, where it has to have a progression towards like it starts at 0 for time and it goes and keeps going depending on what time is, you get the distance. And again, if you just have one point, it seems to me like there's no. It's just one point.
So there's a point, right?
It's not it can't be a function. It's just one point.
All right, couple more people with the nose. Like so, Tom's starting us off, right? Monty, you want to follow up on the no?
There's no input or output.
All right, so that's an awesome statement, and I'd love to follow up on it. Monty's saying there's no input or output. Would someone like to agree or disagree with it?
I agree.
Danny?
I disagree. I think there is an input and output because there's one point. So for that one point, there is an input and output.
All right, so there's exactly how many inputs and how many outputs? So
is there like a rule that says a function has to be a certain length or can it just be one point?
Let's check. Right? Let's see what it is a function is. And for those of you who did your reading as part of your homework, a function is a rule which takes certain numbers as inputs and assigns to each input number exactly one output. The output is a function of the input. Doesn't seem to me like it says there has to be more than one input. Doesn't say there has to be 12 inputs or 15 inputs or 1,000,000 inputs. Go ahead.
I was going to say, like, with the time and distance, it still shows distance in relation to time. It's just one instance of it.
Right, all right, so this actually could be time, and this could be distance, and maybe we only measured this function for, 2 seconds. Sorry, that's a bad graph, but yeah, all right, so this is true. This conversation was nice. We sort of started off wrong but got right, and that's okay. That's how conversations happen, right? So mathematically speaking, you can have one input and one output, and that's a function. All right, good, thanks. Evan, question, comment?
How can you measure the distance or the time of a point?
So at exactly 9:54 and 30 seconds, I'm going to measure your distance, Evan, away from me. You are 8 feet away from me. Okay? That's a point. Now, I agree, sort of what Tom and Monty were saying. In general, we talk about functions as being extended over not several points, but probably an infinite number of points, right?
It's like now, if you move back, you'll be
Yeah,
farther.
I totally agree. But, mathematically speaking, you have an input and you have an output. And you just do that once, and that's okay. Okay? How about, on the heels of that, how about C? A graph with only 2 points. Now, do you agree that a graph with only 2 points could be a function? Okay, but now the question is always the graph of a function? All right, Raffaella, you want to talk to us a little bit?
I think false since they're lined up and it wouldn't have vertical lines.
All right, so Raphael's saying, look, it could be like that, right? And if those 2 points are that way, it's not going to pass the
Can't be
line
two
test.
distances.
All right, good. I like this. This is good. All right, A. If f of x equals 5, then of course f of 2 equals 10. Sam, thought or idea? Wait. All right, hold on. I got to fill it in. We said this one was true. This one was false. And Sam's going with false here. Tell me why.
Because while it might be true some of the times, it might also not be true other times.
All right, so let's see. F of x equals 5 is the function. So what's the input that this function describes? What's the input? X. What's the output? Okay. When you say x, that's a general variable, right? So I'm going to actually talk to you a little bit more about this, Sam. Can you tell me, based on this function, what is f of 1 going to be equal to? This is the input. That's what you put in. And this is what you get out. So if you put an x in, you get a 5 out. If I put a 1 in,
You get a
you're close before. You just said a little too much. 5. You get a 5 out. That's what this rule says. Whatever you put in, I don't care what it is. What are you always going to get out? Everyone say it loud and proud. What are you always going to get out? If you put
2 and you'll get 5.
a 2 in, you're going to get a 5 out. If you put pi in, what are you going to get out? What if you put, oh golly, hold on. Sorry, something went funny. What if you put negative e in? What are you going to get out? Yeah, as a matter of fact, can we take a look? Let's see. This is sometimes temperamental, so keep your fingers crossed. Sometimes this program doesn't like working while I'm recording, so we'll see if it works. You got to have faith. All right. All right, so let's put this function in. So this function, instead of using function notation, we'll use like Algebra 1 notation. The function is f of x equals 5 or y1 equals 5. What's the graph going to look like?
A lot.
Which one? I see this one. I see Andrew's doing this. I hear a line. And Michelle's doing this. Like, so we have a this and we have a this.
I agree with Michelle.
All right. That fast? You're gonna. All right. Corinne's saying horizontal. Let's take a look. Oh, it's nothing. You can't see a thing. Oh, what a bummer. I guess it's not a function. No. I have a bad window. Bad window. So we'll do zoom 6. There's the line, right? It is horizontal, as Corinne said. And if we actually go to the table, you can see the table has, for any input, you get an output of 5. Questions, comments? Evan?
Oh,
No, sorry. Evan.
does that mean f of x it means the y-intercept?
Say that again?
Does that mean f of x means like the y-intercept?
It means in this case, in this case it means that the function is a constant function and it's constantly 5. It does in this case mean that, yeah, the y-intercept is going to be 5 because anything's going to be 5. So f of 0, yeah, that's 5. That's sort of, I don't know, I'm not quite sure if it answers your question.
So if you have like f of x equals 3, does that mean the y-intercept would be 3?
Sure, it actually means any value is going to be 3. It's the constant function that's always equal to 3. Let's see. How about I let you do, actually, here's what I think I'm going to do. Can I show you Calc 0? Because it'll take me like a minute. And then we'll talk about 4, because I think 4 is going to take a little bit more than a minute. Does that sound like a plan? Say yes.
Yes.
All right, so those of you in the home audience, get out your calculators. You may want to play along with this. can someone remind me the function that we played with the very first thing we did on Friday? It was like x squared.
Plus x minus 6.
All right, plus x minus 6. All right. And here's an example of one you could certainly do zoom standard. I'm pretty certain you can do zoom decimal. And all zoom decimal does is it gives you a smaller domain and range, so it sort of zooms in on the origin a little bit. Calculator? That has to be resolved shortly. Like, I'd say definitely within the next day or two. All right, so I'm going to go to zoom 4, which is zoom decimal. And that just gives us a little bit closer view on the origin. Now, you might argue, yeah, it's not really giving you the full picture, though. You're not getting to see that it's a parabola. And I'd say, all right, maybe you're right. Like, maybe I should start with zoom 6 so that I can see that it's a parabola. So if I want to find these zeros, I think, Jennifer, were you saying we could trace on Friday? You certainly can trace. And if you hit the trace button, you can arrow over and you can see that, oh yeah, it's about 2, 0. As a matter of fact, you can even type in a number right now. While you're in trace mode, you can type in 2 and hit enter, and it will take you exactly to that coordinate, 2, 0. All right. But your calculator will actually find the 0 for you if you do second trace, which is the calculate button, and you can calculate 2, the 0. And your calculator is going to ask you a few questions at the bottom. A left bound, and what a left bound means is give me a point to the left of where you want me to find the 0. So I'm just going to arrow over a little bit, and do you see how the blinking cursor is to the left of 2? Say yes. Hit enter, and now it's going to ask me for a right bound, so I'm going to go a little bit to the right of that 0, and I'm going to hit enter. And so essentially now what it's giving me is these 2 arrows, and it's going to find any 0 that occurs between here and here in this region. Okay? And now all I should do is hit enter again. It's asking you to guess. Like it's saying, hey, can you help me out? Can you get closer to where you think it would be? And then you don't have to, and you hit enter, and it says, hey, here's the 0, 2, 0. You can only find one 0 at a time, though, right? So if we wanted to find the other 0, second calc, and if I want a left bound, I'm just going to type in -5. And if I want a right bound, I'm just going to type in 0. So it's going to look for a 0 between -5 and 0. All in this area right here, it'll try to find me a 0, and I'll hit enter again, and it finds me -3, 0. All right? How many people have done that before? How many people first time through that? Okay, good. See? You always learn something sometimes. All right. Do you want to ask a question on that? Is that all right? Great. 10A. Write an equation. Go. Give you like 30 seconds, maybe a minute. And this reminds me a whole lot of Evan's which is a function of which conversation that we had. We hard at work thinking? Miles, thoughts or ideas? Getting there? Sam, thought or idea? You want to share a little bit? You want to try, like courage for the deed, or you don't have to? All right. All right. Monty? So, Monty's saying if the input is 10, then the output is 1. Do you agree with that statement? I'm not saying it's the answer, but do you agree with that statement?
Yes.
If the input is 10, the output's 1, what is the input in this case? What are we putting into the function? Not, and I'm not, in general, not saying 10, but what are we putting in? What does that 10 represent?
Inches of
Perfect. All right. So the input is inches of snow. We're not going to finish, but can you tell me what the output is? Sam, can you call on someone for the output? Inches of rain. Okay. Maybe we'll talk a little bit more about that tomorrow. Maybe we won't. Have a marvelous Monday. You know what your homework is? 1-2-1-1-B, right? Say yes? All right. Have a great day. I'll see you tomorrow.